Happy Thursday, everybody. Here we go, limit 4 to a customer. This is doing stoichiometry with chemistry problems, very much like you did so well yesterday with the s'mores, all right? I'm gonna do the first problem with us. The following are all limiting reagent problems that require you to first write a balanced equation to use for the moles to moles step of stoichiometry. After the equation, each problem requires 2 lines of stoichiometry to determine the lesser amount of product, which is the theoretical yield and comes from the limiting reagent being completely consumed. Then a calculation of percent yield using the actual yield given in the problem. Problem 1 was done for you in my video today. Again, please only give me your final answer in this document and attach somehow a picture of your work, all right? The idea is kind of like this. How many s'mores can you make from 8 graham crackers and 2 marshmallows? Well, 8 graham crackers, you can make 4 s'mores, but 2 marshmallows, you can only make 2. So 2 would be your limiting reagent, all right? Well, we need a balanced equation here. Calculate the percent yield if copper is collected. That means copper is going to be a product from the reaction of 50 grams of zinc and 120 grams of cuprous acetate. So I'm going to say zinc solid plus cuprous means copper plus 1. Acetate, that would be in solution. A single replacement reaction. Zinc takes copper's place. Zinc is a positive 2 ion, so it's going to need 2 acetates to balance its charge. Would also be in solution, and copper gets replaced. All right, we can get copper out of solution. I need to balance the equation. 2 acetate groups. A big 2 in front makes 2 acetate groups, 2 coppers, and I have 1 zinc on both sides. All right, so we've got 50 grams of copper being collected from the reaction of 50 grams of zinc and 120 grams of cuprous acetate in solution. We're looking to solve for our theoretical yield of copper, all right? And we're going to do this separately twice. Once starting with 50 grams of zinc, all right? That's going to be 3 steps, into moles, moles to moles, and out of moles, all right? And we'll get an answer, and we're going to compare that to the answer we get from how many grams of copper, starting with 120 grams of cuprous acetate. I'm sorry, my writing's kind of messy here. All right, I'm going to remove this. All right, this will also be 3 steps. All right, into moles, moles to moles, out of moles. From the periodic table, 65.4 grams of zinc is 1 mole of zinc. And my balanced equation says 1 mole of zinc makes 2 moles of copper. And then out of moles, 1 mole of copper is 63.5 grams of copper. I do the math. 50 divided by 65.4 times 2 times 63.5 is 97.1 grams of copper. Now that may or may not be my theoretical yield. The theoretical yield is going to be the lower of my 2 answers. This says if I use up all the zinc, I could make 97.1. But I don't know if I have enough copper acetate to react with all the zinc. So we're going to go into moles. We're going to add up all these pieces here, and I get 122.5 grams of copper acetate is 1 mole of copper 1 acetate. And then it says 2 moles of cuprous acetate produces 2 moles of copper. That mole ratio is so important. 2 to 2, I can ignore the math when I go through it as far as 1 and 1. And 1 mole of copper is still 63.5 grams of copper. Whoop, my bad. 63.5 grams of copper. I do the math. 120 divided by 122. I can ignore the 2's. Times 63.5 is 62.2 grams of copper. I look at those two answers. It's like saying 4 s'mores and 2 s'mores. I can only make the smaller amount. This is my theoretical yield. All right? My limiting reagent is cuprous acetate, which means zinc is in excess. There'll be a little bit of zinc left over. We'll be going through most of that 50 grams, but there'll be some left over. Percent yield, my bad. Percent yield is comparing an actual yield. All right, and in the problem it says we're collecting 50 grams of copper. That's the actual yield compared to our theoretical yield. Our theoretical yield is here. It's what we calculate stoichiometrically, 62.2 grams of copper. All right? The actual yield will always be less than the theoretical yield. Read the notes from yesterday. Times 100 gives me 80.4%. All right? There's problem number 1. Oh my gosh. Who wrote that on my paper? I miss you all. Keep your stick on the ice.